Today I'm going to solve the LeetCode problem 11, container with most water. So you're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height at position I. Find the two lines that together with the x-axis form a container such that the container contains the most water. Turn the maximum amount of water a container can store. So it's much easier to explain with the picture here. Notice you may not select the container. Okay, so it's easier with the picture here. So we have this height array of 1, 8, 6, etc., where the x-axis is the position plus 1. So like x-axis is position plus 1, but the 0 plus 1, or index, I should say. And the y-axis is actually the value itself. So for this first value 1 here, we have a position of 1, 1, and here it's 2, 8, and etc. And when you want to find the maximum amount of water that a container can store. So to get the area, it's obviously length times height. So what we notice here that the maximum area is of height 7, and 7 by let's see, 1, 2, 3, 4, 5, 6, 7. 7 by 7. Okay, because this guy's position is 2, 8, and 3, 4, 5, 6, 7, 8, 9. And this guy's position is 9, 7. Okay, so obviously the area here equals 9 minus 7. This is to get the width times the height, which is the minimum of these two values, because if we have like the height here at 8, it won't fit. Okay, a lot of water will leak out here. So that's why you have our height at 7. The water will fit. So this would be min of 8 and 7. Width is 9. Oh, sorry, I meant 2 here. 2. So that's 7 times 7, which is 49. Okay. How can we approach this problem? Well, one thing we can do is look at each element in the array here. So if you're like 1, 8, 6, 2, 5, etc., we have an element in focus, and we loop through the rest of the array and calculate the height there using this exact formula. So the area between, calculate the area. So the area between 1 and 8 would be 2 minus 1 times 1, which is 2. Between 1 and 6 would be 1, 2, 3 minus 1, 2 times 1, 2, etc. And we update to max area variable accordingly. And then for next iteration, we have another element in focus, which would be 8 this time. And we do the same thing. So this is the element in focus, and we iterate on all the elements after that, calculating the area. And if you have an area greater than the max area, then we update max area. This would be O of n squared time. It's not very efficient, but we can do better. So notice that to get a large area, we need a large height, okay, and a large width. And we want to maximize these two. So why not just start out with the maximum width? So let's start at the extreme ends, at the very beginning, at the very end, and calculate the maximum width there. And then later we can optimize by incrementing these pointers to see if there's another max height we can look at. So in this case, between 1 and 7, our area right now is, let's see, 1, 2, 3, 4, 5, 6, 7. 7 times 1 is 7, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 1, which is 8 times 1. So this is our area right now. So why not, actually, in hopes of finding a larger height, increment this pointer to this guy here. So we do sacrifice the width a little bit, hoping to find a better height. And here in this case, let me erase that. So our max height right now is, or max area, sorry, is 8. Now what's our area, our current area? It would be 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 2 times the minimum, which is 7, is equal to 49. And this is obviously greater than 8, so 49 is now our max area. And we can keep going. So every time we have a smaller height, we can increment or decrement the pointer, depending on which end you're at, in hopes of finding a better height. We're sacrificing width in hopes of finding a better height and a larger area here. Okay, so if we keep running through the algorithm, we get to this pointer, which would be 8 minus 2 times, what is this, 3? Obviously smaller than 49. And then we get to this guy here, which is 8. 9, 8, 7. 7 minus 2, which is 5 times 8, which is 40, still smaller than this guy. And then in the case where both the heights are the same, it kind of doesn't matter where we go, because sorry, it doesn't matter which pointer we move, because we could choose to move this pointer here, and we get, what is this, 6 times 6 height compared to 8 height. Okay. Or we could do this guy here and compare 6 height to, what is this, 4 height. Yeah, it kind of doesn't matter. So this solution would be O of n here. What we could also do instead, if they're the same height, is check the value next to them and choose the one that is higher. So obviously 6 is greater than 4, so we choose this one. Okay, we could also do that too. And this is O of n time. Okay, now to code this up. So we want to initialize our result to be 0. And then our left pointer is at position 0, right pointer at the very last position, length height minus 1. Okay, and while left is less than right, we don't want to calculate when left exceeds right. We want like these two intervals, left here, right here. We don't want right here, left here. Area is equal to right minus left times minimum of the left pointer and the right pointer, because the smallest value is our limiting factor in the area. And the result is going to be the max of itself and the area we just calculated. Okay, so you've done that, and now time to shift the pointers. So if height at the left corner is less than the height at the right corner, left plus equals shift left pointer. Else if height at the left corner greater than height at the right corner, shift right. We want to keep the largest value we have at the current pointers. Else if they're the same, if height at the current left and current right pointer here and here are the same, we want to check these next values and just get the highest one, because this could be like 1,000,000 here, or it couldn't. We just want to get the maximum one. If let's copy this. Left plus 1 is less than right height minus right minus 1. Right minus equals 1. Yeah, we want the largest one because this could be 1,000,000 here, and once you calculate that, we see 1,000,000, or 8 is less than 1,000,000, and this could be 1,000,001. So we just want the largest one. Else left plus equals 1. And then finally, result. Type right here. Okay, let's try compiling. Result. And I'll try submitting. Awesome. Yeah, thanks for watching.